Continuing with section 1.8, we are now looking at example 3, but before that there is a note that if you have a matrix, a 2 by 2 matrix, which has entries 1, A, 0, 1, where A is any real number, then the transformation T of x is equal to AX is called a shear transformation. Means in which the A looks like this: 1, A, 0, 1. So A is any real number. So now example 3 says let A be the matrix 1, 3, 0, 1. So here we are taking A to be 3. Then we define the transformation as from R2 to R2. So it's taking vectors from R2 and mapping them on vectors R2 in R2 again. So and the transformation is given by A times X, the matrix, standard matrix times the vector. So now it says find the images of the corners of the square defined by the lines x is equal to 0, y is equal to 0, x is equal to 2, and y is equal to 2, and draw the square and its image. So first thing we do is we find the images of those vectors or those points. So the corners of the square are at 2, 0, 0, 0, 0, 2, and 2, 2. And here is the square I have drawn it down here. So I gave those points names A, B, C, D so that it's easier for us to understand which points to join together. So I did some work here already. I have found the images of the points. So the point 2, 0, which is the point A, that is not going anywhere. That is going to stay put. So the A point is going to stay where it is. And then we have the next I will look at is the 0, 0. So 0, 0 is going to stay put where it is. That's what we found. T of 0, 0 is 0, 0. Actually, any point on this line will stay here. So this whole line will stay here, or this whole side of the figure will stay here. Now the point 0, 2 is mapped onto 6, 2. So if you look at this one, the point 0, 2, T of 0, 2 is coming out to be 6, 2. So the point is going to be 6, 2. But here, which point? The C point. So this let me call this C dash or C prime. Okay. Next is the point 2, 2, and we saw that the 2, 2 is mapped onto 8, 2. So 8, 2 will be here. So now how we join them? Well, this will be D prime. So now in the picture, in the square, A is joined to B, B is joined to C. So now B will be joined to C prime. Go like this. And then D and C prime and D prime will be joined. And then A to D. So A to D prime. Because remember, A and A prime are same. B and B prime are same. So A prime, B prime, C prime, and D prime. These are our new points. So you see what happened? It looks like the square has been stretched to the right. So this is how you can show what the shear transformation does. Next example says that T be mapping from Rn to Rm be a linear transformation, and suppose that T of u is equal to V. So the image of u under T is V, some vector V. Show that T of negative u will be equal to negative V. So we have to show T of negative u will be negative of T of u. So we start with, because it's a linear transformation, so T of Ru is going to be R times T of u. Why? Because T is linear. Now T of minus u can be thought of as T of negative 1 into u. So this means our negative 1 is the R scalar. So this will be equal to, according to negative 1 times T of u by the linearity property. So now this is just negative T of u, but T of u is V. So we get it's equal to negative V. We have shown the result. Next example, it says that define T from Rn to Rm as T of x is equal to Ax plus B. Show that T is not linear transformation when B is not equal to 0. Now this is called an affine transformation, and these are important transformations in computer science. So we have T of x equals Ax plus B. So now in order to show that or check whether it is linear or not, we start with our conditions, the two conditions that we have. So we say let x and y, or let uv, you can take uv, let uv be in Rn and C, you can take any letter, C be a scalar. Well, C will be used in the second condition. So the first condition is we want to see what is T of u plus B. T of u plus B, according to the definition of the transformation, will be equal to A times u plus V plus B. Now I can distribute the matrix. I get AU plus AB plus B. Now remember, if this is equal to T of u plus T of v, then this condition is satisfied. But what is T of u plus T of v? So this will be equal to au plus b plus av plus b. So if I look at this, this gives me au plus av plus 2b. So now you see these two are not the same. Not same. So we say the 2t of u plus v is not equal to t of u plus t of v. Hence, t is not linear. Okay. Next example. Show that t defined by t x1 x2. So this is the vector x, so it looks like it's in R2. We are in R2, and this is also in R2 because we have only two components. First one is this one, 2 x1 minus 2 absolute value of x2, and the second component is x1 minus 4x2. And we have to show that this is not linear. The main thing that will work here, or the idea that you have to use is to remember, is that absolute value of a plus b is not equal to absolute value of a plus absolute value of b for any numbers. Okay, for any numbers, not vectors, sorry, numbers. A plus b is not equal to a plus b absolute. So the condition is a plus b absolute is not equal to absolute of a plus absolute of b. In general. Okay, so we again start by using our t of u plus v. So let u equals u1 u2, v equals v1 v2. Now I could take x equals x1 x2 and y equal to y1 y2, or uv doesn't matter with the names of the vectors. We have to look at the property. Now u plus v, if you want, you can write it like this: u plus v is equal to x u1 plus v1 and u2 plus v2. So which will be equal to, now u1 will be, what is t of u1? T of u and T of v. That's what we are going to find now. T of u will be equal to, according to the transformation, will be equal to because that will be T of u1 u2. It will be u1 minus 2 absolute value of u2 comma u1 minus 4 u2 and T of v will be v1 minus 2 absolute value of v2 comma v1 minus 4 v2. And T of u plus v will be equal to maybe I'll write it a little bit down here. T of u plus v u1 plus v1 minus 2 times absolute value of u2 plus v2 comma and the second coordinate will be u1 plus v1 minus 4 parentheses u2 plus v2. Now I can distribute this 4 over here. I can distribute this 4 over there, but I cannot distribute the 2 in here. I mean, I can bring the 2 inside, but I cannot split it. And that's why you can, it won't give us the tu plus tv. So which is equal to u1 plus v1 minus 2 u2 plus v2. I cannot split it, so it will remain as it is, comma. Now here I can write it as u1 minus 4 u2 for u2 plus v1 minus 4 v2. And when I add these two, T of u plus T of v from there, so then I get u1 plus v1 minus u1 minus 2 absolute of u2 comma, actually I'll skip one step and write the, so u1 plus u2, we say u1 plus v1, we are adding these two, so the corresponding coordinates or terms will be added. This term will be added to this term. So u1 plus v1 minus 2u2 absolute, and then minus 2 v2 absolute, comma u1 plus v1 minus 2u1 minus u2 minus 2v2, and these are not equal to each other. So this shows us that T of u plus v is not equal to and because absolute value u2 plus v2 is not equal to absolute value of u2 plus absolute value of v2. Therefore, this is not linear. Okay, the last two examples I'll do in the third video.